In programming, loops are used to repeat a block of code multiple times instead of writing the same instructions over and over. Loops let you tell the computer, do this task X number of times. Unity scripting often uses loops for tasks like spawning, animating elements, managing waves of enemies, and so much more. So a loop is a block of code that can run more than one time. Let's see some loops and how we can set the number of repetitions. In this video, we'll be using this awesome race card to demonstrate how a loop works on each lap. This is the full code, but for now we'll focus only on the loop part. The rest is just for visual effect. Feel free to try it out on your own, tweak some values and observe the changes, or if you prefer you can simply use debug log to check the output in the console. Alright, let's take a look at how the loop behaves during each lap. First up, we have the for loop. For loops are perfect when you know exactly how many times you want something to run. The syntax is this. You write for, then open a parenthesis. Inside the parenthesis there are three components: where the repetition starts, when the repetition stops, and how much the counter variable increases on each iteration. We usually use the letter I as the counter variable. If you don't remember the syntax and you use Visual Studio, you can type for and then press tab. Let's say our race card will complete 5 laps. This ++ here means we're increasing the value of I by 1 on each repetition. It's a shorthand for this. If you need to increase it by a different amount, you can adjust it like this. Let's break down what's happening here. The loop checks if I is less than or equal to 5 before each iteration. If the condition is true, it runs the block of code inside the loop. Once the condition is false, the loop stops. So the card completes laps 1 through 5 because the condition keeps the loop running until I becomes 6. Next, let's talk about while loops. These are perfect when you don't know in advance how many times the loop needs to run. The syntax is straightforward. All you need is to type while, followed by condition inside parentheses. So now it's pretty self-explanatory. While this condition is true, run this block of code. As long as this condition is true, the code inside the loop will continue to run. For example, let's say our cart keeps racing until it runs out of fuel. Here's how that would look in code. In this example, the fuel starts at 5. The loop keeps running as long as fuel is greater than 0. After each iteration, fuel decreases by 1. Once the fuel is empty, the loop stops. You can also use a while loop to perform tasks similar to a for loop. Now let's see do-while loops. These are similar to while loops, but with one key difference. The block of code inside the loop always runs at least once before the condition is checked. This is especially useful when you need to guarantee some initial execution. The syntax is simple. First, write do. Inside curly braces, write the block of code you want to execute. Then, after the closing brace, write while followed by the condition in parentheses. So, do this code while this condition is true. In this example, the race starts with 5 laps. The code inside the do block runs at least once. Then, after the first execution, the condition is checked. If it's true, the loop runs again and again and again until there are no laps left. So, why use a do-while loop? Let's say we want to guarantee the cart starts racing even if the lap count is mistakenly set to 0. A do-while loop ensures the race starts regardless of the initial condition. Finally, let's talk about Foreach-Loops. These are perfect for working with collections as they allow you to iterate through every element. Here's an example. Let's say we have an array of checkpoints. Don't worry, we will cover arrays in the next video. For now, just know that Foreach is a fantastic tool for navigating through collections like this. The Foreach loop cycles through each checkpoint and we can also log its name as the card completes a lap. It's clean, efficient, and ideal for tasks like processing checkpoints, player inventory, or enemy waves. So there you have it, C# loops. I hope you learned something from this today, and thanks for watching.